Imagine an object older than your sun, older than your planet, older than every atom that makes up your body. An object that has been drifting between the stars for 10 billion years, in the dark alone, ever since the star that made it died and left no record behind. In 2025, a small telescope in the mountains of Chile catches a faint smudge of light moving the wrong way, not orbiting, not falling, passing through. By the time astronomers finish their measurements, they know three things. It came from outside our solar system. It is only the third object of its kind ever seen by human eyes, and it is, by some estimates, twice as old as everything that exists around us. This is the story of a visitor that should not exist, a traveler from a place that may have already ended, a frozen messenger from a chapter of the universe that closed before our sun was even born. What is 3I Atlas? Where did it come from? Why is the chemistry inside it unlike anything ever measured in our solar system? Why are some scientists, the serious ones, the ones with Nobel Prizes nearby, beginning to suggest it is not what it appears to be? And why, after 100,000 years drifting in the dark, did it choose this exact moment to come close enough for us to look? Welcome to Outbound. On July 1st, 2025, a robotic telescope in the Atacama Desert in Chile is doing what it does every night. The system is called ATLAS, the Asteroid Terrestrial Impact Last Alert System, built by NASA originally to spot asteroids that might hit Earth. That night, ATLAS catches a faint object moving across the constellation Sagittarius, a small smear of light magnitude 18. Nothing remarkable at first. The data goes into the queue, and an algorithm flags it for follow-up. Within hours, other telescopes are pointed at the same patch of sky. The European Southern Observatory telescopes in Hawaii, in South Africa, in Arizona. They watch the smear move over a few nights, and they calculate its orbit. What they find stops them cold. The orbit is hyperbolic. To understand why that single word changes everything, you need to understand something about gravity. Every object that belongs to our solar system, every planet, every asteroid, every comet that has ever circled our sun, is bound to it. They move in ellipses, closed loops. They come and they go, but they always come back. A hyperbolic orbit does not come back. It is the trajectory of something passing through, not something that lives here. Something traveling fast enough that the sun's gravity cannot hold it. 3I/Atlas, as it would soon be named, was moving at 130,000 miles per hour, 60 kilometers per second, too fast to ever have been one of ours. It came from somewhere else. In all of recorded human history, with thousands of years of skywatching, with millions of telescope observations, with billions of asteroids and comets catalogued, only two other objects have ever been confirmed to come from beyond our solar system. The first was called Oumuamua, discovered in 2017, a cigar-shaped wanderer that vanished before astronomers could study it properly. The second was a comet called Borisov, seen in 2019, clearly a comet, clearly interstellar, gone within months. And now, in 2025, the third. But 3I Atlas was different. It was caught early, months before its closest approach. The world's most powerful telescopes had time to look. Hubble, the James Webb Space Telescope, ground-based observatories all over Earth, even a NASA spacecraft called Lucy, on its way to study asteroids near Jupiter, was instructed to turn its cameras and stare. What they saw when they looked was something nobody was ready for. To understand why 3I Atlas matters, you have to understand what a comet is. Most people picture a comet as a bright streak in the sky, a tail, a spectacle. But that is only what we see. What a comet actually is something far stranger, a piece of the past. When a star like the sun forms, it does not form alone. It forms inside a vast cloud of gas and dust, slowly collapsing under its own gravity. Most of that material falls into the star itself. Some of it spirals outward into a disk and clumps together into planets, and some of it, the leftover scraps too small and too distant to ever become a world, freezes into chunks of ice and rock that drift in the outer dark. those chunks are comets. Because they formed at the very beginning and have been frozen and untouched ever since, a comet is something a planet can never be. A comet is a sample of the original material, the chemistry of a star system's birth, preserved in ice. Every comet astronomers have ever studied, from Halley to Hale-Bopp to the one we crashed a spacecraft into in 2005, has been one of ours. A sample of our sun's origin, a frozen page from our own beginning, until 2017. When Oumuamua came through, astronomers realized something extraordinary. If a comet is a frozen archive of how a star system was born, then an interstellar comet is a frozen archive of how a different star system was born. It is a message sent by no one, carrying the chemistry of an alien world. If we could catch one of these messages and read it carefully enough, what would it tell us? Oumuamua disappeared too fast. Borisov was too dim. We never got a real answer. Then, in 2025, the third one came. Bright, slow enough to study, headed for the inner solar system. The James Webb Space Telescope, the most powerful telescope ever built, was given priority observation time. For the first time in human history, we were about to read the chemistry of a star that was not our own. What Webb found should not have been possible. When light passes through gas, the gas absorbs certain wavelengths. The pattern of absorbed wavelengths is called a spectrum, and a spectrum is like a fingerprint. Every molecule on the periodic table leaves a different one. By reading the spectrum of a distant object, you can know what it is made of without ever touching it. In the autumn of 2025 and into 2026, Webb stared at 3Us Atlas for hours at a time, breaking apart the light reflected off its dusty coma. The first surprise was the carbon dioxide. 3I's Atlas is venting CO2 at a rate roughly 8 times higher than its water. In a comet from our solar system, that ratio is almost always reversed. Water dominates and carbon dioxide is a minor component, but 3I Atlas is mostly carbon dioxide, as if it formed somewhere much colder than our outer solar system. A place where even water could not condense the way it did around our young sun. The second surprise was the water itself. When Webb measured the water vapor coming off the comet, the team checked the ratio of regular hydrogen to its heavier cousin, deuterium. This ratio is a kind of cosmic thermometer. The colder the place a water molecule formed in, the more deuterium it carries. 3I Atlas has more deuterium in its water than any comet ever measured. In plain English, the ice in this object is the coldest water humans have ever studied. It formed in a place colder than the outermost reaches of our solar system, colder than the Oort cloud, colder than the gap between the stars. Then came the third measurement, the age. A research team led by Matthew Hopkins at Oxford used the European Space Agency's Gaia Star catalogue to trace 3I Atlas's motion back through the galaxy. The velocity, the trajectory, the angle of approach, all of it pointed to a single conclusion. This object did not come from the part of the Milky Way our sun sits in. It came from the thick disk, an older, deeper layer of the galaxy, populated by stars that formed repaired 8 to 12 billion years ago. A separate study by Martin Cordiner at NASA Goddard reached the same answer through chemistry. The low level of heavy carbon, the cosmic ray exposure on the surface, the processed dust. Every line pointed at the same number, between 10 and 12 billion years old. Our sun is 4.5 billion years old. 3I Atlas predates our solar system by more than 6 billion years. Hold that number in your mind, because it changes everything. 6 billion years. It is a number so large the human brain refuses to feel it. Let's try a different way. When 3I Atlas was formed, the Earth did not exist. The sun did not exist. There was no Mars, no Jupiter, no asteroid belt, no moon. The piece of space where you are sitting right now was nothing. Empty gas, drifting hydrogen waiting to collapse. The atoms in your body, the carbon in your hands, the oxygen in your lungs, did not yet exist in their current form. Most of them were still cooking inside the cores of stars that have since died. In that universe, in a star system whose name we will never know, around a sun that has long since burned out and scattered. A cloud of gas and dust did what clouds of and dust have been doing since the beginning. It collapsed and made a star. Around that star, in the dark, far from its warmth, a chunk of ice formed and froze and waited. Then something happened. A planet, perhaps, swung too close. A passing star tugged just enough. Whatever it was, the gravitational dance was wrong, and the chunk of ice was thrown. Not falling toward the star, not orbiting, but flung out into the dark between the stars at thousands of miles per hour. And then it traveled. For 10 billion years it traveled, through the thick disk of the early Milky Way, when galaxies were still colliding and stars were dying in close pairs, through the formation of new stars and the destruction of old ones, through the birth of the supernova that, 4.5 billion years ago, seeded the cloud that became our sun, through the formation of Earth, through every extinction, every ice age, every empire. It was already older than the sun when life began on this planet. It was already older than the sun when the dinosaurs went extinct. It was already older than the sun when human beings stood up on two legs and looked at the sky for the first time. And then, on a clear night in July of 2025, a robotic telescope in Chile, controlled by software written by people whose grandparents' grandparents were not yet alive, finally saw it. The star that made it is almost certainly gone, burned out, faded into a white dwarf, a neutron star, or a black hole. Whatever solar system formed around that star is long dead. Its planets, if any survived, are frozen tombs. 3I Atlas is a postcard from a sender who no longer exists. A message sealed in ice addressed to nobody that nevertheless arrived. So far, every scientist quoted in this story agrees. 3I/Atlas is a comet. An extremely old comet, an extraordinarily interesting comet, but a comet there is. However, one exception. His name is Avi Loeb. He is a professor of astronomy at Harvard, the former chair of the astronomy department, and the founder of the Galileo Project, which uses telescopes to look for signs of alien technology in our solar system. Loeb has, for years, argued something that most of his colleagues find embarrassing. We should take seriously the possibility that some of the interstellar objects passing through our solar system are not natural. They might be technology, probes, ships, debris from civilizations whose stars died long before ours was born. He started saying this in 2017 about Oumuamua and was widely mocked. When 3I Atlas appeared, Loeb wrote essay after essay arguing that some of its properties, its precise trajectory through the inner solar system, the lack of an expected tail in early observations, the unusual brightness profile, deserved serious investigation as possible signs of artificial origin. His essays in November of 2025 accumulated 5 million reads. His interview on the Joe Rogan podcast on the same subject was watched 7 million times. To be clear, the scientific consensus is against him. The water vapor, the carbon dioxide, the dust, the rotation, the chemistry. Everything Webb has measured is consistent with a natural comet. An old one, a strange one, but natural. And yet, Loeb's point, the one that has refused to die, is not that 3I Atlas is definitely an alien probe. His point is that we have no idea what an alien probe would look like, because we have never found one. And until we know what to look for, we have no way of telling the difference between a very strange natural object and a very normal artificial one. He has spent his career pointing out an uncomfortable fact. The universe is 14 billion years old, while our species has been capable of building space probes for 68 years. If even one civilization in the history of the galaxy was 1 billion years ahead of us, we would have no way of recognizing their leftover hardware. None. 3I Atlas, in his view, is exactly the kind of object we should be looking at very carefully before deciding what it is. So far, his colleagues have decided it is a comet, a magnificent, ancient, irreplaceable comet. But the wider universe, the universe that includes everything Webb has not yet measured, has not finished answering. In December of 2025, 3I Atlas made its closest approach to Earth, about 170 million miles away. That is almost twice the distance from us to the Sun, too faint for the naked eye, visible only through Sirius telescopes. It was here with us for a few weeks, and then it began to leave. In the months that followed, the data kept coming. In May of 2026, scientists publishing in the journal Nature reported that 3I Atlas contains a form of water with isotopic ratios unlike anything ever measured in our solar system. Not just slightly different. Different in a way that suggests it formed in a fundamentally different chemical environment. In June of 2026, Webb detected methane in the comet's coma, along with chemical signatures that astronomers described as baffling. By now, 3I Atlas is millions of miles further than it was when this script was written. It is on its way out, returning to interstellar space, returning to the dark. It will not be back. In 10,000 years, it will be in the outer edges of our solar neighborhood. In 100,000 years, it will be among other stars. In 1,000,000 years, it will be unreachable by any technology we can currently imagine forever. And here is the part that should bother you. We caught it by luck. The Atlas telescope was looking at the right patch of sky on the right night. If it had passed 3 years earlier, before the telescope was online, we would have missed it. If it had passed at a slightly different angle, behind the sun, we would have missed it. If the alert had not been flagged in time, we would have had weeks to study it instead of months. We saw one ancient interstellar comet in 2017, another in 2019, another in 2025. That's 3 in 8 years. Astronomers now estimate that there may be 1 or 2 of these objects inside our solar system at any given moment. We just cannot see them. The universe has been quietly delivering letters to our doorstep for the entire history of our species. We only learned how to read them 8 years ago, and the third letter we read came from a sender who lived before our world began. There is an idea, sometimes attributed to Carl Sagan, that the cosmos is the way it is in part, so that we, who are made of the cosmos, can wake up and recognize ourselves in it. Every atom in your body was forged in a star. Most of those stars are now gone. The iron in your blood, the calcium in your bones, the carbon that makes up every thought you have ever had, was once dust drifting between dead suns. 3I Atlas is that dust, still drifting. Frozen, untouched, the same molecules that watched the early galaxy take shape. The same chemistry, the same water, sealed for 10 billion years. When Webb spectrograph caught the light reflecting off its surface, what we were really doing, in a way that should not feel small, was reading the diary of a star that has been dead for longer than our planet has been alive. Most of human history has been the story of a species standing on a planet and looking up, wondering whether anything out there knew we were here. We sent probes, launched Voyagers, and carved messages on golden discs. We assumed we would have to do all the talking. It turns out the universe has been talking to us the whole time. We were just not looking hard enough. 3I Atlas is one piece of one star system that no longer exists. There are billions of star systems that did exist, do exist, will exist. Some of them, statistically, must have produced their own observers, their own scientists, their own children, lying on their backs in the grass, looking up. Some of those observers by now are dust too. Their stars are gone and their atoms are drifting somewhere in the dark between the suns. Maybe, in 1 billion years, on a planet that does not yet exist, around a star that has not yet ignited, someone will look up at a faint smear of light moving across the constellation we once called Sagittarius. They will turn a telescope on it, and they will see, with the same astonishment we felt in July of 2025, that a visitor has arrived. A messenger from a place that may have already ended. A letter from us. We will not be there to read theirs. But the cosmos does not require both ends of the correspondence to be alive at the same time. That is what 3I Atlas has come to teach us. A message can outlive its sender. a piece of a dead world can carry, frozen inside it, the only proof that the world ever existed. The universe is not silent. It is just very, very patient. If this journey out into the dark has made you look at the night sky differently, subscribe to the channel.